This video is some notes and investigation on solving quadratic equations by the quadratic formula. So let's start out and look back here at what we've already done. We can solve quadratic equations graphically, so where we graph them and find the x-intercepts. We can solve them by factoring, where we factor and then set each factor equal to 0. And we can solve by square roots when we take the square root of both sides. But not all of these methods work all the time very nicely. So we also need to solve quadratic equations when these methods do not work. So there's one method that works for all quadratics, and that is the quadratic formula. So the quadratic formula starts out with x equals, and then on the top we have the opposite of b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. You will need to memorize this formula. It's something that will be used in math from now on. So to use the quadratic equation, we must have our equations in standard form. Standard form for a quadratic is ax squared plus bx plus c is equal to 0. So a is the coefficient of x squared, b is the coefficient of x, and c is the term that does not have an x with it. All right, let's try an example. Solve this first equation, x equals positive 2x squared minus 10, using the quadratic formula. It says to give exact simplified solutions. That means we're not using our calculator on this. We're giving exact answers. We might get square roots, we might get imaginaries in there, and we just have to simplify. So the first thing we need to do to solve this is to put the equation in standard form and identify what a, b, and c are. So I need to be equal to 0. I prefer to keep my x squared term positive, so for this one I would actually move the x over to the left. So my 2x squared is going to stay where it is, but my x is going to move over to the right by subtracting x from both sides, so it will now be a negative x, and then the minus 10. I do this so that I can look, my a is the coefficient of x squared, which is a 2. My b is the coefficient of x. Since there's just a subtract there, the coefficient is really negative 1. And my c is the constant term, or the term without an x, so it would be equal to negative 10. The next thing I'm going to do is to substitute the values of a, b, and c into the quadratic formula. So remember, my formula starts out with x equals, then this was the opposite of whatever b was. So the opposite of negative 1. You could just write down a positive 1 when you were doing that if you wanted to. Then we have plus or minus the square root. I'm not going to simplify anything while I'm plugging in. I've got b squared, which is negative 1 squared. Then I have minus 4 times a times c. My a was the 2, and my c was the negative 10. All of that was over 2a, and again, a was positive 2. So now I need to simplify, and I'm going to make sure I follow the order of operations. So the first thing I'm going to do, I'm going to simplify the opposite of b, because that was out in front, and then I'm going to do my b squared, and then I'm also going to do my 4 times a times c. So this part right here, my 4ac becomes positive 80, and the other ones just became positive 1. All right, the next thing I'm going to do is I'm going to combine, following my order of operations, my b squared and my 4ac. So this switched to become a positive 80, so I now have an 81 underneath the square root. The next step will be to simplify the square root. So I had the square root of 81, so that's just 9. Sometimes everything will come out from the square root, other times it won't. So realize at this point that I have in here a plus and a minus. What does that mean? It means I have 1 plus 9 over 4 and 1 minus 9 over 4. If I had to write a description for that, I would say break into 2 solutions, probably. And it was because the plus or minus. Now, if this were a square root, you wouldn't have to necessarily write them as 2 separate solutions. You could leave the plus or minus in there. The reason for this one that we want to separate them is because we can actually work this out now. 1 plus 9 is 10, and 10 over 4 is equal to 5/2. That's a much nicer answer than the plus or minus. 1 minus 9 is equal to -8, and -8 over 4 is equal to -2. So the two solutions to this quadratic equation are x equals -5/2 and x equals -2. We also could have written this like a solution set with a -2 and a 5/2. Doesn't really matter to me which way you write it. All right, here's another one we can try together. So I have 2x equals -2x squared plus 9. First thing I'm going to do is to get this into standard form where I have my quadratic equal to 0. Again, it doesn't matter if the 0 is on the left or the right. In this case, since my x squared was negative, I would like to move that over to the left by adding 2x squared to both sides so that my 2 is positive. My plus 2x was already positive, and when I move my 9 also over to the left, that will now become a -9. So I've got my a, b, and c, where my a is going to be the 2, that's the coefficient of x squared. My b is going to be +2 as well, that's the coefficient of x. And my c is going to be -9, or the constant term. Now I'm ready to substitute into the quadratic formula. That started with x equals, I had the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, and I'm just going to plug my numbers in. The opposite of b was 2, so now I'm going to have a -2 up there on top. Then I had plus or minus b squared, so that was 2 squared, minus 4 times a, which was 2, times c, which was -9, all over 2a, and a again was 2. So let's start doing some simplifying here. For my opposite of 2, that's -2. Next, I'm going to do 2 squared, which would be +4. Then I'm going to multiply my minus 4ac. -4 times 2 is -8, and -8 times -9 is +72. All of that was over 2 times 2, which is 4. Next thing I need to do is to combine what's underneath my square root, my b squared and my 4ac. So that gives me 4 plus 72, which is 76. So then I'm going to write my direction here. What did I do? I combined my b squared and my 4ac. Just be careful with the signs there, whether you're adding or subtracting. It started as a minus 4ac, but if you multiplied and turned it to a positive, then make sure you're actually adding. All right, now we're into the simplifying stage. We've got this square root of 76 right here, which I need to simplify. So the square root of 76, I would normally make a factor tree to do that. 76 is 2, that's what I meant to write, times 38. Then I can break that down further. 38 is 2 times 19. 19 is prime. So I can take out a set of 2's right there. And I have x equals -2 plus or minus 2 square root of 19 over 4. So because I have 2's on the outside of the square root in my first term and on the bottom, I can do some reducing here. I can take 2 as the GCF of the top and pull it out in front. If I pull that out, this -2 that was first will become a -1. This 2 square roots of 19 will become just square root of 19. The reason that I did that is because now I can reduce a 2 and the 4, and my final answer right here will be -1 plus or minus the square root of 19 all over 2. We could leave it like that, especially if it were multiple choice and it were written that way. Or if it were multiple choice and it weren't written that way, I won't make you write it like this, but you should recognize that there are two solutions, the -1 plus the square root of 19 over 2, and the -1 minus the square root of 19 over 2. We definitely want to emphasize that since it's a quadratic equation, x squared, there should be two different answers. All right. Here's another one for you to try. I'm going to have you guys pause the video while you try this one. Just realize that in your first step, when you're lining this up to be x squared times bx plus c, that your a is 3, and then for your x term in the middle, there wasn't one. So your b is really a 0, and your c is a 20. So go ahead and pause that and give this one a try. Okay, so on this one, we started out, we plug into the quadratic formula up here in this top step. Then I do my simplifying. Since I have the opposite of 0, that's just 0, and I didn't write anything out in front. You can write a 0 there if you want to. Then in the middle, I do 0 squared minus 4 times 3 times 20, which works out to negative 240. Since I have a negative underneath the square root, I need to take that negative out and call it I. I also have to break down the square root of 240. The square root of 240 can have two sets of 2's that come out, so there's going to be a 4 out in front, but then I still have a 3 and a 5 that have no partners, so I'm still left with the square root of 15 underneath. Then I have 4 over 6 that are both outside of the square root, so they can reduce to 2 over 3. It was plus or minus. Again, you can leave it like this, or if you wanted to, you could rewrite it as two separate answers of negative 2i square root of 15 over 3 and positive 2i square root of 15 over 3. I usually just leave it the way it's written in the circle right here, but if it were multiple choice, they may have written it this way, so just be sure you recognize both. You can also give number 4 a try. Remember that you have to rewrite it first into standard form by moving this negative 4x over to the left. And then you can pause the video while you try that one, and then we'll check it. All right, so in this one I rearranged by adding the 4x. So my a is now a 2, my b is 4, and my c is positive 3. So I went ahead and plugged into the quadratic formula. The opposite of 4 was negative 4. When I did 4 squared minus 4 times 2 times 3, that becomes 16 minus 24, which is negative 8. I need to simplify. Since I have a negative underneath the square root, that can come out and become an I, and my 8 simplifies to 2 square root of 2. The final step is to recognize that all three parts, the negative 4, the 2i square root of 2, and the 4, are all divisible by 2. So if I divided 2 out of the negative 4, it becomes negative 2. If I divide the 2 out of the 2i squared square root of 2, it's just gone, and I'm left with my I square root of 2. And then on the bottom, when I reduce 4 divided by 2 is just 2. So I can leave it like that again, or I could write it as two separate solutions if I wanted to.